So we're going to try to piggyback on our last video where we were writing the equation of a tangent line, and we're going to call this video just simply part 2, and we're going to make some extensions and throw a couple extra curveballs at you. In the last video, we were given a point of tangency, and let me move this bear. So there's our point of tangency, and we found the instantaneous slope of that point and ended up writing the equation of that tangent line right here. So in the last video, they told us what the x-coordinate was going to be, and then you had to find the y-coordinate and you had to find the slope by using the derivative. Well, check out how things are going to change in this video. In tonight's video, they're not going to give us the x-coordinate, which you'll see here in a few seconds in the first example. Okay? So, just to recap, in our last video, they gave me this number, and then I had to find the slope, I had to find the y-coordinate. Tonight, however, in this video, let's see here. I'm going to give you the slope, and then you've got to use that to find the point of tangency, or the x and y coordinates. So things are going to change just a little bit. So here we go. We're going to write the equation of a line tangent to f of x equals x squared, and it happens to be parallel to the line y equals negative 6x plus 2. So let's draw ourselves a little picture and try to visualize what's happening here. Here is f of x equals x squared, and if I drew this line, the y-intercept is a 2, so it's going to cross the y-axis right there, and the slope is negative 6, so it's a very steep negative slope. Now that line that I just drew is not tangent to the curve, but there is some other line tangent to the curve that's parallel to that black line. And so I'm going to estimate right around here in that neighborhood right there that if I drew a tangent line at that point, it would be parallel to the black line. So the question is, what is the x-coordinate of that point of tangency? Let's say in our notebook x equals question mark. Now the only thing I know to be true is that both lines have to have the same slope, which happens to be negative 6. So we can say to ourselves that the slope has to be negative 6. So what am I going to do? How am I going to find this x-coordinate that I don't know? What we're going to do, now think about this. Whenever I say slope, I want you to think of the derivative. Okay? So we know that the derivative has to end up equaling negative 6. So let's take the derivative of this function here, which we know to be 2x, and let's set that derivative function equal to negative 6, and then solve for x. Look at that. And it makes sense. It kind of fits our graph. That x-coordinate right here is a negative 3. Now what's the y-coordinate? Let's plug this negative 3 back into the original function, and f of negative 3 equals negative 3 squared, which makes 9. So if we put this all together, y minus 9 equals negative 6 quantity x plus 3. And that is the equation of a tangent line that's parallel to this line. Here's a very similar example with just a few extra challenges and twerks to it. We're going to write the equation of a line tangent to f of x equals radical x and parallel to 8y equals x plus 16. So let's draw a picture of radical x, and it's going to curl in this way starting at the origin. And before you draw this line right here, we have to solve for y. So if I divide every term by 8, I'll get y equals 1/8 x plus 2, and I'm going to try to graph that. The y-intercept is 2, and it's got a very slow, gradual, positive slope of 1/8. Now this line that I just drew in black is not parallel to radical x, or I should say it's not tangent to radical x, but there is some tangent line out there that would be parallel. And so let's say there's my point of tangency, but I just don't know the x-coordinate. But you do know that the slope is going to be 1/8. So take your derivative and set it equal to 1/8. What is your derivative? Remember, let's rewrite radical x as x to the 1/2. Now you can take the derivative, which would be 1/2 x to the negative 1/2. Rewriting that in a friendlier form, would be 1 over 2 radical x. Now set that equal to 1/8. Cross multiply. Divide by 2. And then square both sides. And I think you're going to get, whoops, what did I just do? And if I square both sides, I'll get x equals 16. So now I do need to plug this back into the original equation and say f of 16 would be radical 16, which equals 4. And if I put it all together, we could say y minus 4 equals 1/8 quantity x minus 16. And that's the equation right there. That's your final answer of this red tangent line at the top of the page. Our third and final example is working with the equation 1 divided by x, which we know is a rational function. It's got one vertical and one horizontal asymptote that looks kind of like this. And it's got to be parallel to 16y plus x minus or equals 8. But let's solving for y, let's subtract the x over first, and then we'll divide every term by 16. So negative 1/16 x plus 1/2. Now if I try to graph this line right here, it's a tough one to graph. The y-intercept is going to be a 1/2, and the slope is going to be a super slight negative, which is 1/16. Now this one's a very unique problem because there's actually going to be two tangent lines that are parallel to that one. I think there's going to be a tangent line right around there that's tangent to that x-coordinate. And then there's going to be another one over on this side, and that x-coordinate would also be a question mark. So there's going to be two answers to this particular problem. Now what do we know the slope has to be? We know that the slope has to be negative 1/16. So we're going to take our derivative, and let's see. Let's just rewrite f as x to the negative 1. Then the derivative is going to be negative x to the negative 2, which could be rewritten as negative 1 divided by x squared. And let's set negative 1 divided by x squared equal to negative 1/16. If I cross multiply, I get negative x squared equals negative 16. Divide both sides by a negative 1. And then take the square root of both sides, and you get plus or minus 4. So don't forget your plus or minus right there. So if we go back up here just a little bit, this x-coordinate is positive 4, and this x-coordinate's negative 4. Let's see if we can fit this on there. So let's say x equals 4, x equals negative 4. This y-coordinate would be 1/4. This y-coordinate would be negative 1/4 by plugging them back into the original function 1 divided by x. So I'm going to write two separate equations, one for each of those points of tangency here. Here's what it'll look like. Okay, if I do the positive one in the first quadrant, I would get y minus 1/4 equals negative 1/16 quantity x minus 4. Okay. If I did the line back in the third quadrant, it would be y plus 1/4 equals negative 1/16 x plus 4. So those are the two respective equations of each tangent line there. So I hope that made a little sense, and you can go download the PDF that corresponds to this video and try a couple on your own.